All right, so let's practice through what we learned in the last video on these two examples that we're going to do. So I want you to think with me as we do these. So first off, we're going to 3 from the right. And you need to really, in your mind, know what that means. It means that x is never less than 3. You're coming to 3 from above 3. So x could be 3.2, 3.1, 3.01, 3.001, so on and so forth. Not just those numbers, but numbers like that. It's going to 3 from the right, i.e. from above 3. All right, now, one of the first things you want to do when you're working out limits like this, where you can't just use the direct substitution property, is you want to look at the form. And so the form of this limit, I claim, well, the top is going to 9 and the bottom is going to, you got it, 0. So the form is 9 over 0. And so this means that the limit is either, hopefully you know the answer by now, right, plus or minus infinity. And so you've got a 50-50 chance of getting it right at this point, although the goal is not just to guess, but to understand. So now we need to think very, very carefully about the signs of this thing. We need to watch the signs. So let's realize that the numerator, I'm just going to say the top is going to 9. The top is always positive. It's positive as x goes to 3 from the right. It's going to 9. You can see that. You can plug in anything near 3 above 3, and 3 times that is going to be positive. That should be clear to you. The top is positive. The bottom, though, let's see if it's positive. Maybe it is, maybe it isn't. You're going to 3, and you're plugging in something bigger than 3. And here's my advice. If you're struggling with this, actually write down a computation. Plug in 3.01 minus 3 into the bottom. And look what you get. You get 0.01. And that means that the bottom is positive. And you can actually see, look, if you plug in something bigger than 3, that something a little bit bigger than 3 minus 3 is always going to be positive. And so we can see that the bottom is always positive as x goes to 3 from the right. And now, if the top is positive and the bottom is positive, everything is positive. I know it's blowing up, and so I know now that it's going to plus infinity. This is the work. So you can say, okay, I'm going to write it out. Don't just say, like, write down infinity and circle it. It's nice to make a mathematical statement, so I'm going to write down the statement, x as x goes, the limit is x goes to 3 from the right of 3x over x minus 3 is infinity. And now I'm going to box that whole statement. All right, so let's do one more example. So this one, we're taking the limit as x goes to 1, and I didn't say from the right or from the left, and so hopefully we can get something. Maybe it's different from the right and the left, and the whole thing simply doesn't exist. I don't know. But let's begin by studying the form of this limit. So the form of the limit, as x goes to 1, 2 minus x is going to 2 minus 1, which is 1. So the form is 1 over, and now you can see as x goes to 1, the bottom is going to 0. So the form is 1 over 0, and immediately you know that the limit is either plus or minus infinity. And so now, again, we're going to think very carefully. So as x goes to 1, the top is going to be positive. It's going to positive 1. That's all that you need. That's easy enough to see. The top is always positive. The bottom, this one worked out really nice. There's a square. The square is going to keep everything positive. So the bottom is always positive. And so now I can conclude that, so let's say it like this. So we'll say, thus the limit as x goes to 1 of 2 minus x over x minus 1 squared equals infinity. And yes, it may seem a little tedious to you to rewrite the problem, but mathematics is about half correct computing or proving or whatever you're doing, and then the other half is communicating. And so if you can write a little bit extra to make it clear, that's a really good thing. So in both of these examples, the limit went to infinity. I should have maybe changed the numbers and made one of them go to minus infinity. But let me just show you. If the bottom had been negative here, a positive over a negative would be negative, and so you'd have a negative infinity. Or if the top had been negative here, then you'd have a negative over a positive is negative, and so you'd go to negative infinity. And maybe if they were both negative, if this one was negative and this one was negative, then it would be positive again. So we'll see an example like this further on in the videos. So we'll end this one here, and then we'll keep going.